Hi, hello everyone. Welcome back to Akki-Vikki Math. This is Akshaya, 6th grade. Let us solve this problem today, which was appeared in RMO. Let ABCD be a convex quadrilateral, PQRS be the midpoints of AB, BC, CD, DA respectively. So they have said the PQRS are midpoints of the sides of this quadrilateral. And whenever we have midpoints, always look for similar triangles by SAS property. So we have over here, so we'll draw the diagonal AB. We'll draw this diagonal BD. Let's draw the diagonal BD. And from that, we have P and S are midpoints. So A is P and S are midpoints. P is a midpoint, Q is a midpoint, R is a midpoint, and S is also a midpoint. So we have A, P and S are midpoints. So by SS property we can write by SS property we can write SAP similar to DAB. SAP similar to DAB. Now we'll check if the order we wrote is correct or not. So let's write the side ratios. SA divided by DA equal to AP divided by AB. So we have SA divided by DA will be equal to, this is also equal to SP divided by DB. And we have SA divided by DA equal to 1 by 2 because S is the midpoint. And we also have AP divided by AB equal to 1 by 2 because P is also a midpoint, and the common angle, which is angle A. This is a common angle. So the order we wrote is correct, and we got SP divided by DB equal to 1 by 2. And similarly on this side we have Q and R are also midpoints. So again by SS property we can write. Again by SS property we have QCR similar to BCD. QCR similar to DCB. QCR similar. Now we'll check if the order we wrote is correct or not. So let's write the side ratios. QC divided by DC equal to CR divided by CB equal to QR divided by DB. Now let's check. QC divided by DC. This QC divided by DC. We don't know the side ratio of QC divided by DC. We want the, because we have the side ratio of QC divided by BC. So the order we wrote is wrong. Now let's write the correct order. Now we'll write the correct order, which is QCR is similar to QCR similar to BCD. BCD. Now let's write the side ratios. Just QC divided by BC equal to CR divided by CD equal to QR divided by BD. QR divided by BD. And we have QC by BC equal to 1 by 2 because Q is the midpoint. So this is equal to 1 by 2. And also CR divided by CD equal to 1 by 2 because R is also a midpoint. And we have the common angle over here, which is angle C. So the order we wrote right now is correct. Now again we got that QR divided by BD equal to 1 by 2. So now they have said, now we'll continue the question such that the triangles AQR and CSP are equilateral. So the triangles AQR, which is AQR, this is the triangle AQR. They're saying that AQR is an equilateral triangle. So an equilateral triangle has all angles equal to 60. So we'll label the angles. This angle equal to 60 and this angle this is equal to 60 and this angle is also equal to 60. They also said the CSP is also an equilateral triangle. This is CSP. So this angle equal to 60. This angle will be equal to 60 and this is also equal to 60. Now we have labeled all the sides. Okay. So we have over here we have PS equal to dB divided by 2. Let's write it. PS equal to dB divided by 2, right? dB divided by 2. And we also have QR equal to dB divided by 2. So this is also equal to QR. And we have some equilateral triangles having these both sides. So we have PS as C in the triangle CSP. This is the triangle CSP. We have CP as we have PS as one of the sides of the equilateral triangle. So we can write this is also equal to CS divided by PC. CS equal to PC. CS equal to PC. And we have also QR over here in the equilateral triangle AQR. We have the side QR. This is the triangle equilateral triangle AQR. We have this side QR. So we can write this is also equal to AQ equal to AR. Equal to AQ equal to AR. So we have all of these are equal. Now we'll label all the angles. Now in this similar triangles, we did not label the angles. So let's label the corresponding angles which are equal. We have angle S of this triangle equal to angle D of this triangle, and we also have angle A is the common angle. Now angle P equal to angle B. Angle P of this triangle equal to angle B of this triangle. So we got if AB is the transverse line, we have these triangles are equal, and if AD is the transverse line, these two are equal. So we can say that SP is parallel to DB. Have SP is parallel to DB. And over in this pair of similar triangles also, let's label it. Angle Q of this triangle equal to angle B of this triangle. These both are equal, and also we have angle R of this triangle equal to angle R of this triangle equal to angle D of this triangle, this angle. And these both are equal. So if CD is the transverse line, we have angles, these both are equal. If CB is transverse line, these both are equal. So we can say that QR is also parallel to BC. And these are also parallel. Now we'll indicate the angles by these parallel lines. So we have angle over here equal to 60, and these both are parallel, and if AR is the transverse line, we can label angle over here also equal to 60. And over here also we have this angle equal to 60. So if AQ is the transverse line, we can label this angle equal to 60. And now we can label, and if these both are also parallel lines, and if AR and AQ are transverse lines, then these angles are also equal to 60. We'll label them later. Now we have over here, okay, so we have that this angle equal to 60, right? Now we'll label by this angle. We have these both are also, yeah, these both are parallel, right? So we have this angle equal to 60, and by that we labeled it. And if this angle equal to 60, then if PC is a transverse line, then this angle is also equal to 60. And if these both, we have these both also. If PC is the transverse line again, this angle is also equal to 60. And similarly, we have this angle equal to over here, this angle. We have this angle equal to 60, and these both are parallel. So again, this angle is also equal to 60, and these both are also parallel. So again, we have this angle is also equal to 60. And now we have labeled the angles by parallel lines. Let's look for some more parallel lines. So let's check. By alternate angles, we'll check. And now if BD is the transverse line, we'll check if there are parallel lines. If BD is the transverse line, let's check it for alternate angles. And if we have labeled, if we have missed any angles labeled, so we have 60 over here, and by vertical angle, this angle is also equal to 60. Now let's check for, okay, right now we have got one pair. We have BD as a transverse line, and we have AR. Let's take AR and PC for example. BD is the transverse line, and we have this angle equal to 60, and this angle equal to 60. So by alternate angles, we have proved that AR is parallel to CP. So we have proved that AR is parallel to CP. And like this, we'll find one more pair of parallel lines. So let's do that. We'll find one more pair. So let's see. Again, if BD is the transverse line, we have AQ and CS. Let's take these again. Let's take these, and we have B as transverse line. Then this angle equal to 60, and this angle also equal to 60. So again, by alternate angles, these both lines are parallel. AQ is parallel to CS because over here 60 and over here 60. So we got AQ is parallel to CS. AQ is parallel to CS. Now we got these both pairs of parallel lines. Now we have AR and CP are parallel. We have also AR and CP are equal over here, and also AQ is parallel to CS. AQ is also equal to CS. AQ equal to CS. So we have parallel lines, and those parallel lines are also equal. They have a length equal. Let's take AR and CP for example. They both are parallel lines and have equal lengths. And whenever if that condition appears when the quadrilateral related to those sides is a parallelogram. So let's check what quadrilateral is related to those sides. AR and CP. We have APCR. We have APCR right now. APCR. So we have this quadrilateral. AR is parallel to PC, and both are equal. So we can say APCR is a parallelogram. So this is a parallelogram. And whether we have AP is parallel to RC. AP is parallel to RC, and we also have AP is lying on AB and RC is lying on CD. So we can say from this, we can say that AB is parallel to CD. AB is parallel to CD. So we got this pair of parallel lines in the convex quadrilateral. Now we'll take the second pair of parallel lines, which is AQ and CS. We have AQ is also equal to CS, and the quadrilateral related to those sides is we have AQ, this is AQ and this is CS. So ASCQ, we have the quadrilateral ASCQ. That's right. Have the quadrilateral ASCQ is a parallelogram. So right, ASCQ is also a parallelogram. Is parallelogram, And from this we have, this is the parallelogram and this is the parallelogram. And from this we have AS is parallel to QC. AS is parallel to QC. And we can see that AS is lying on AD and QC is lying on BC. So we can say those both lines are also parallel. From this we can say AD is parallel to BC. Now we have, in this big convex quadrilateral, we have opposite sides are parallel. So we can say that ABCD is a parallelogram. ABCD is also a parallelogram. And they are asking to prove that ABCD is a rhombus. Now we prove that ABCD is a parallelogram. In order to prove that ABCD is a rhombus, we have to prove all sides are equal. Now this is the parallelogram, right? So let's draw the diagonal AC, because in a parallelogram, the diagonals of that parallelogram bisect each other, and we have drawn the diagonal BC. So let's draw BD, and now we'll draw the diagonal AC. Let's draw the diagonal. This is AC. And now if these both are bisecting each other, so this is the intersection point. Let this be O. So O is the midpoint of AC and BD. And we have DO. The length of DO is also equal to DB by 2. So I can write it over here. Okay, leave it. So O is the midpoint of AC and have DO equal to, in the triangle ADC, we'll take ADC now. In triangle ADC we have DO equal to BD by 2. DO equal to BD divided by 2. And it is also, O is the midpoint of AC. So we can say DO is the median of the triangle ADC. And this is also a median. And we'll take other points also. Now we took DO. Now we'll take CS, because S is also a midpoint and we have CS. Over here CS equal to DB by 2. Now we can write it. CS equal to DB divided by 2. DB divided by 2, and it is also a median because S is a midpoint. So CS is also a median. And we also have another one, which is AR. R is also a midpoint, so we can say AR is also a median, and we have over here AR equal to DB by 2. So you can say AR equal to DB by 2, and it is also a median because R is the midpoint. It is also a median, and we have these three are medians of the triangle ADC. And if all three medians are equal, the only possibility of all these three are equal is when ADC is an equilateral triangle. So we can say that ADC is an equilateral triangle. ADC. So we have AD equal to AC equal to DC. AD equal to, if ADC is an equilateral triangle, we can say that AD equal to DC. AD equal to DC. ADC is an equilateral triangle. Equilateral triangle. So we can say AD equal to DC. And we also said that ABCD is a parallelogram, so opposite sides are equal. And we have AD equal to BC, so this is equal to BC, and CD equal to AB. CD is equal to AB. So we have proved that all sides of this quadrilateral are equal. So not only ABCD is a parallelogram, it is also a rhombus. We have proved that it is a rhombus. No, it is a rhombus. We have proved it. And they are also saying that determine its angles. Okay, let's determine the angles. And we have just now proved that ADC is an equilateral triangle. So this angle will be equal to 60. This angle is equal to 60. So this angle is also equal to 60. So this is also equal to 60. And these both lines are parallel. And if AD is a transverse line, sum of the supplementary angles equal to 180. So you can say this whole angle equal to 120. And if this is 120, then this angle is also equal to 120. So determine all the angles and prove that ABCD is a rhombus. Okay. So also prove that ABCD is a rhombus. Now the concepts we have used in this question are: first, we have used midpoints, and second, similar triangles, and third, medians. No, not medians. Parallelogram. We have used parallelogram, and fourth, we have used medians, and fifth, we have used equilateral triangle. Equilateral triangle. Lateral triangle. And first, we have used midpoints to prove that some triangles are similar, and from similar, we have proved that some some quadrilaterals are parallelograms, and whether the big quadrilateral called ABCD is also a parallelogram, and whether the diagonals are bisecting each other. So we took a triangle and drawed its medians, and by that we have said that ADC is an equilateral triangle, and by that we have proved that all sides of this quadrilateral are equal. So we have proved that it is a rhombus. For better understanding and practice on these concepts, please follow our classes by clicking on the link in the description. And don't forget to like, share and subscribe. Bye bye.